Okay, this is our last video for these notes. Last part, we're just looking at a specific type of sequence and its series, arithmetic sequence. And I kind of referenced this at the beginning. This is when we have a common difference. So the general formula is a sub n equals dn plus c, where d is our common difference, and c, oops, c equals the first term minus that common difference. So really, I like to think of it as basically, what would the term be before the first term? So an example, let me give you an actual sequence that's arithmetic. 3, 8, 13, 18, and so on. Take a look at that for a second and see if you can come up with a formula that represents that sequence. Alright, well, our common difference keeps on going up by 5, so our common difference is 5. A sub n equals 5 times n. Plus c, that's just the first term minus that difference. So 3 minus 5 would give us negative 2. But like I was saying before, if you basically take this pattern and just go backwards, go back one term, that's going to give you what c is. So we know it's going up by 5. We just go down by 5 to the left here. That gives us c. If we wanted to find the sum of an arithmetic sequence, that formula is s sub n, the sub up to the nth term, n times a sub 1 plus a sub n, all over 2, which is really what you learned last year, and what I said was kind of like the one that we saw at the very top of these notes. Right? That one up here, a little too far, n times n plus 1 all over 2, right? The number of terms times, this is the last term plus the first term, all over 2. Basically, we have the same thing here. Number of terms divided by 2 times the first term plus the last term. This just is more general. It doesn't have to be 1, 2, 3, 4, so on. So this is our sum formula. If you want to find the sum from k equals 1 to 20 of 5n minus 2, well, we could break this down like we did in the examples earlier into 2 parts and do it that way, or we can use this formula because it fits this arithmetic sequence. So it's going to be the number of terms, which is 20, times first term. Well, if we put 1 in here, 5 times 1 minus 2 gives us 3. You can kind of see up there also. Plus our 20th term, if we put 20 in, 5 times 20, 100 minus 2 gives us 98, all over 2. So that would give us 1010. Again, we could break it down like we did up there, but this is just another special formula for arithmetic series. If it fits this formula, a number times n plus another number. Last thing we're going to look at today, 1 and 2 down at the bottom. Basically, we want to express these series, if they're being added, as a sum in sigma notation. For this one, number 1, we need to look at this. We do have an arithmetic sequence. If we just look at the numbers, negative 3, 1, 5, 9, they have a common difference. It's going up by 4. So we know the common difference is 4. And the c value, the one that would be just to the left of this, would be negative 7. Right? If we go backwards 4, that would give us negative 7. So our formula in here would be 4 times n minus 7. We're doing this, oops, I did n, so we can do n equals 1. We could use k, we could use any variable. N equals 1 up to, this is our first, second, third, fourth, fifth, sixth term. So we're going up to 6 for this one. Go ahead and take a look at number two and try this one. Now, for number 2, kind of help you get started. It looks more complicated, obviously, but break it down. Look at the top. The numbers in the top, those numerators, are all an arithmetic sequence. Then look at the bottom. There's an arithmetic sequence there. So basically, what we did here, only we've got to do one for the top and one for the bottom. So I'm going to give you 30 seconds to try that one. Let's take a look. For this one, over here we can do from n or k, whatever. Let's do k this time. K equals 1 to k equals 4. I'm sorry, we don't have to put the k equals. Just k equals 1 to 4. Now, we know that because there are 4 terms. The top, we're just going up by 1 each time, so our common difference is 1. So that's 1 times k. If we figure out what c is, we just have to go 1 back from here, so 1 minus 1 is 0. So on top, all we have is k. First term, second term, third, fourth. On the bottom, it's going up by 5, so we have 5 times k. And if we find out what c would be, we're just take this first term minus 5, we get negative 1. Alright, your homework for tonight is down here. And tomorrow we'll start to make some connections between sums and integrals.